Welcome. This question says, consider a parallel plate capacitor that is used to create a uniform electric field of 9 newtons per coulomb. What is the change in potential energy experienced by a 4 coulomb positive charge that is moved from point B to point A? So here's point B and here's point A, and we're moving in that direction. So my D is in that direction. And what I can say is that, well, from general terms, my potential energy difference is equal to the charge times my potential difference. And my potential energy difference in a uniform field will equal my charge times my potential difference in a uniform field. And this will equal, well, Q times minus ED. So, looking at my question, my potential energy difference is going to equal Q, and Q is 4 coulombs positive. So let's put that down as plus 4. And then I have a minus, it's multiplied by a minus, and my electric field is 9 newtons per coulomb. And then my D, if I look at my diagram, I see my D is going to be 3 meters. Now, here's the thing. The electric field is pointing downwards from positive to negative, but my motion, my displacement, is pointing upwards in the opposite direction to the electric field. And so I put that down as a negative. It's in the opposite direction. So then I say, well, delta U is equal to, I have a minus and a minus making a plus. So that's going to be plus. I have 4 3s are 12, 9 12s is 108. That's 108 joules. So my answer is positive 108 joules. I got the positive sign because although there's a negative sign in the equation for potential difference, my displacement was in the opposite direction to the electric field, and so I characterized my displacement as being a negative 3 meters. If the displacement had been in the same direction as the electric field, it would have been a positive 3 meters. Well, it raises the question of, does this make sense? So let's visualize. So here we have our positive electrode, and then somewhere down here we have our negative electrode. Remember, potential is like height in a geography map. So the positive potential is higher than the negative potential. The electric field is like an embankment or a slope. The electric field points from the positive to the negative. And in this case, I have a positive charge which is like a boulder, and I'm moving that boulder uphill. If I move a boulder uphill, it contains more potential energy. If I move a positive charge against the electric field, it contains more potential energy. And so the sign does make sense from an analogy point of view. So there we have it.